what is the key fundamental of DMVPNs, means why basically we use the DMVPN and all. So be with me and I will try to give the best learning experience over the DMVPN. I'll explain each and everything from scratch. What is the GRE tunnel? What is the IPSEC tunnel? How the DMVPN is going to build? What is the mGRE? What are different phases of DMVPNs and how this DMVPN is going to be used for the any kind of the your production environment. If you want to use that, then what is the key concept and how we can use it. So let it be like I'll explain these all things in detail. So you guys are going to understand. Even I'll explain how the topology is going to look like. What is the DMVPN topology and what is the key principle and how we can build the underlay. What is the NBMA address? What is the NHRP? And how we can route the traffic from hub to spoke and spoke to spoke. These all things we're going to get in these sessions. So if you have any query and if you're watching on the YouTube, please feel free to ask, right? I will try my best to respond and I will try my best to give the learning experience, best learning experience. So let's just start, guys. So first of all, we have to understand what is the DMVPN and why basically DMVPN is used. Before I go and explain the DMVPN, I need to understand what is the VPN concept. So if you are aware about the VPN concept, so VPN is basically a virtual private network. So you might be have seen a VPN that is known as the virtual private network. So my first ask is why we need a VPN? Why we need a VPN? And then once we get the answer why we need a VPN, then we'll try to explore what is my GRE tunnel and what is the mGRE tunnel, and then how this VPN become DMVPN. DMVPN is like it is going to be multi-protocol VPN, which is going to be used for the dynamic multi-protocol VPN, which is going to be used to build the dynamic tunnels. So you can see in my PPT, we have to explore these all fundamentals. So if I go here, you can see this is my DMVPN topology. And in this DMVPN topology, if I go here, we have to understand how the network has evolved in the enterprise networking, and then what is the private network and what was their like problems and how this VPN are basically become an essential part of any networking. And then after we have to understand the DMVPN architectures, how this DMVPN architecture is going to look like and why this DMVPN, that is a dynamic multi-VPN is going to come in a picture. So let's start doing the one by one. I will just use this PPT as a reference, but I'll explain each and everything, whatever I have a knowledge based on that, my production environment, right? So let's just start and let's just start on starting the VPNs. So first of all, the VPNs. What is a VPN, guys? Anyone know? So if I talk about the VPN, so virtual private network, this VPN having one requirement. The VPNs are defined into multiple part. Means this is going to be L2 VPNs. Okay, this is going to be L3 VPN. There is another VPNs, and we also have the IPSEC VPN. Okay, and also we have the DMVPN. So we have to understand each and every concept for the L2 VPN, L3 VPN. So let's suppose we have the VPLS network. What is a VPLS network? That is a virtual private like network, and that is MPLS. That is a multi-level protocol network. That is a MPLS network. So in VPLS circuits, we are going to use the L2 VPNs. Means it's a kind of the EIGRP cloud is going to be there. On that entire cloud, we have the layer 2 technology, like VLAN-based technology is going to be there. And MPLS is going to be multi-protocol level switching. That is going to be your give the L3 VPNs. Means end to end, you have the private CEP concept is going to be there. CCNP concept is going to be there, and then you're going to be entirely transfer your traffic privately from one location to another locations. So even L2 is the private line VPNs, private VPN. This is also private VPN. But L3 having the more flexibility. This is like for the small network. If you have the branches in the within the country, within the city, then you can use this technology. But it's also going to be costly. But this is the more costly and very popular solution, that is the MPLS. So these are basically used widely across the globe. And in top of that, we have the IPsec VPN. So why IPsec VPN in a picture? And when I talk about the VPNs, everyone is going to think about the IPsec VPN only. Nobody's going to talk about the L2 VPN, L3 VPN. They're only going to talk about the IPsec VPN. They talk about the encryption, they talk about the integration, they talk about the confidentiality, that the CIA fundamental, that's VPN is going to give in a, like all kind of a solution. But in short, popular VPN is MPLS VPN. Okay. And you can use the L3 MPLS VPN, but this VPN is very costly. That's the only problem. Costly means you have to bring the private lease line. And when you're going to private lease line end to end, you have to pay a lot. So if I don't want to use the MPLS circuit, I want to use the internet. Then what is my solution? The solution is I can use the VPN that is known as the IPSEC VPN. Why IPSEC VPN over internet? Because internet, let's suppose you have the branches and these branches are going to be different locations. This is my branch 1. This is my branch 2. In between we have the internet cloud. So what is going to happen on the internet cloud? If these two branches are going to talk, whatever data you're sending over these lines, any hacker sitting on the internet who can snip your data and they can manipulate anything from your data, because this is the shared transports, not dedicated. Means thousands of millions of billions of people are just using this line and your data is never going to be secure. It's going to be open pipe and anyone is going to snip your data, can do the manipulation and all. So that is going to create a problem for you. So to avoid that situations, what we have, if we go for the MPLS, then MPLS, if you replace this cloud as MPLS cloud, then what is the problem? You can build the private lease line. That's okay. And this private lease line is going to be dedicated for your company. So nobody is going to understand what data you're sending and receiving. But problem is in MPLS, your cost is going to be high. So if you want to save your cost, then this MPLS link is not going to be required. This MPLS is not required. I use my internet circuits only, and over internet I can build the VPN tunnel that is known as the IPsec tunnel. So this is going to be give the flexibility where my data is going to be like confidential, means encryption is going to be there, my data integrity is going to be there, right? And also whatever end-to-end your data is saying it's going to send, that is going to be secure. Means there is no kind of the hacking is possible, because you are doing to do the peer authentication, you're going to do the confidentiality, data integrity and hashing and all. So this is going to give the end-to-end encryption. So this is the VPNs, right? So you understand the plane, this is the IPsec VPN, and I talk about the L3 VPN. So this is the costly, this is not costly. Then why we required suddenly DMVPN? Then also we have to understand why dynamic VPN is going to be there. Then we have to understand DMVPN in more depth. But first we have to understand basic principle. Where is the problem and how this problem is going to be sorted by the different kind of the method by using the different tunnels. So if I talk about the DMVPN, so before I talk about DMVPN, let's understand how the design is going to happen for the IPsec VPN. If you're going to make the design, then how it is going to happen? So let's suppose you have the branch, this is the one branch. This is the branch 1, and now this is the branch 2, this is the branch 3, this is the branch 4, right? And this is the branch 5. It's similar, you're having the hundred of branch, thousands of branch, depend on the where you're having a site. And these all branches are going to be connected with the internet. That's fine. Then what is going to happen? You're just going to make the connectivity with the all branch, and these branches must be talk to each other. So what is going to happen? Everyone require the IP signal. We require with this one. We require tunnel with this one. Okay, we require tunnel with this one. Just look at it. This we require tunnel with this one. So mean one router, how many tunnel I have? Similarly, this router is going to require tunnel with this one. This router is going to require tunnel with this one. This router is going to require tunnel with this one. So if you talk on this router point of view, how many tunnel? 1, 2, 3, 4. Total 4 tunnel we have. Means whatever you branch, if you have the thousands of branch, minus 1 means 99 tunnel is going to be happen. If you want to build the full mass tunnel topology, means if you want to make the communications between full mass means every branch is going to talk to every branch. So the problem is that you have the very large number of tunnels, and these tunnels are going to be very unscalable, very complex. It is going to create very much problem for you, right? That is the one thing. Another design can be, but you have to create that much very long configurations. So if you have the very small site, like you have the 10 sites, 20 sites, it's okay. But if your site are going to be increased 100 sites, 200 sites, 500 sites, 1000 sites, even more than that, and if you're going for this kind of solutions, it is going to be totally fail for your network and not as scalable for your network. So what is the solution? What is the next solution? So another solution for the VPN IPsec we have, this is the one solution. Another solution we have, IPsec VPN. We can use not the full mask, we can use the hub and spoke topology. Okay. Then what is going to happen? In that situation, I require this one of the branch R1. This is going to be act as my hub router. Let's suppose this is the branch 1. Similarly, I have the branch 2. We have the branch 3. We have the branch 4. We have the branch 5. Again, we have the internet. This is my internet ISP. This internet is going to be connected in this way, this way, this way, this way, this way, this way. Then what is going to happen? You can build a tunnel only with hub. Means now you see every site is going to be having one tunnel, but your hub having multiple tunnel. Means hub means if you have the 100 site minus 1, 99 tunnel is going to be happen in hub. This is the hub location. So this is going to be having a lot of tunnels, but branches only one tunnel, one tunnel, one tunnel, one tunnel, one tunnel. So right now I have the total 5 branches including the hub. So 5 minus 1, 4 tunnel is going to be created on the R1. Understand? So what is the problem in this design? There is no problem as such, but the problem is this router, if it is going to be crashed, then what is going to happen? Entire branch is going to be dead. And this router required a lot of configuration. This is going to be required a lot of kind of route processing. This required to be like a lot of memory consumptions. Required to buy a very high-end router. You have to always manage. So this is the second. If you're going to deploy the very large scale of sites and you have the very hub related deployment, then it is going to create another problem where your hub having the always dependency. And if your hub location is going to be crashed, let's suppose data center is going to be crashed, you are going to lose every branch connectivity. Just think about it. Let's suppose router node goes down, but let's suppose for any region of data center having any kind of fire activity, any natural climate is going to be happen, any kind of the flood is going to be there, any kind of earthquake is going to be there, then what is going to happen? You're going to lose this all, and even for different country where there is no earthquake, no flood, they're also going to be impacted. So that's the risk we have in this VPN solutions. So end result is if I'm going to use the VPNs, IPsec, I can use that for the small kind of the scale network. But if the large scale of the network, this is going to get again a problem. So now the third evolution of the VPN, which has been introduced by the globally, especially Cisco, that is known as the DMVPN. Now DMVPN especially that is going to give the dynamic multi-point VPN. So multiple VPNs, not multi-point. Let me see. So we have to go there. Yeah. Dynamic multi-point, sorry. Yeah, that's correct. So dynamic multi-point VPNs. So this is basically going to be a VPN. In this VPN, what is going to be happen? Let's suppose I have a hub locations. Okay. And I have the different branch again. This is a branch 1. This is the branch 2. This is going to be branch 3. This is going to be branch 4. Right. Again, I have the ISP, internet. These branches are connected this way. So what is going to happen? These DMVPN solution is going to give the flexibility. You do not require always you have to build tunnel with the hub. These branches dynamically also can build the tunnels. If they want to talk directly, they can build the tunnel directly. There is no problem at all. Means if this want to talk this one, they can build the directly like connectivity. If this want to build this one, it can build it directly. Means you don't have to do any manual configuration. Dynamic automatic tunnel is going to build. Even the hub want to talk, they can build the tunnels. So beauty of that, you don't have to do the every tunnel configuration on every router. You just enable the DMVPN and they come with a different phase. The phase 1 and that is the phase 2 DMVPN and then the phase 3 DMVPN. So what solution I'm talking about, these all are the phase 2 and phase 3 solutions. Phase 1 still going to work with the legacy kind of the IPsec VPNs. Means always you have the hub dependence. I'll discuss about what is the phase 1 of the DMVPN. That's not recommended, but phase 2 and phase 3 is going to give the very flexible kind of the your tunnel creations between the branch to branch, between the hub to branch, and even any branch want to make communication to anyone, because they have the dynamic tunnel. Even you don't have to do always configuration for the all branch locations. And even if once you create the DMVPN, then they are going to create the your all tunnel, and they use the multiple things. Whenever you configure DMVPN, they use one of the protocol that is known as the NHRP. I'll discuss what is the NHRP. This is known as the Next Hop Resolution Protocol. Okay, this is the NHRP. This is the more or less similar to the ARP request. Means they basically discover your NBMA address, non-broadcast multiple address. There is the NBMA address, which is known as the non-broadcast multi-access network. I will discuss what is the NBMA address and all. But in short, right, we having a problem with the VPN solutions. We having a problem with the L3VPN, because the only problem with L3VPN is the cost. No other problem we have, right? But the VPN having a problem to build a tunnel. You have to get a lot of manual tunnel, either in the full mesh technologies or even the hub and spoke technology. And in case of both of scenario, you're going to get a lot of kind of problems, and that is going to create the issue for you. So to fix that issue, we have to use the L3 VPNs. Okay. So I hope you guys understand these all concept. Now, there is a concept we have to understand, that is the GRE tunnel, okay, versus mGRE tunnel. We have to also understand what is the GRE and what is the mGRE tunnel. So if I talk about the GRE tunnel, this is never going to use by the DMVPN. This is a normal GRE tunnel. And why use the GRE tunnel? Let's suppose we have the one of the branch location here. Okay. This branch is connected with the ISP, like internet, and we have the another branch here, this branch too. And if you want to make the IPSEC, you can make the IPSEC. There's no problem. So you can create the IPSEC tunnel. These IPSEC tunnel is going to be created. But the problem with the IPSEC tunnel, the IPSEC having one problem. This is the very means the benefit of IPSEC. It is going to be give the secure connectivity, secure connections. Means everything is going to be encrypted. So you can make the any communication over the IPsec, and that is going to be secure. But what is the problem with IPsec? IPsec only support the unicast. Unicast means you can only do the static routing. Means if you want to run these two branch inside of this tunnel, like BGP, OSPF, right? EIGRP, because OSPF, EIGRP, these all are support the multicast packet. So if you are going to use that, it is not going to be possible. And in that situation, what is going to happen? Only we end with the static routing. So this is secure but not flexible. This IPsec is not flexible. So what is GRE? So GRE is basically, it's going to build a tunnel. If you want this branch and you want to build a GRE tunnel, let's suppose this IPsec tunnel, I'll use another color. Let's suppose I use the white. If this site want to build the GRE tunnel over this internet, I can build the GRE tunnel also. No problem. So GRE is going to build between these two branch. This is my GRE, which is known as the generic routing encapsulations, right? This GRE is going to build. But what is the best part of the GRE? This GRE having a very much flexibility, means it's a very flexible. This GRE is flexible, means this can support your BGP, OSPF, even you want to configure the RIP and EIGRP or ISAS. Whatever protocol IGP you want to use, it can be. Even the static route are going to support it. So it's very flexible. Any dynamic routing protocol you want to run under this GRE, it is possible. But the problem with GRE, it's non-secure. Non-secure means any traffic you're sending on the GRE, it is not going to be make security on top of that. So anyone sitting on the internet who can snip the data of your GRE and they can take out your data and they can do any kind of manipulations of your data. You guys understand? So this is the problem with the GRE, right? So what is solution? Means if I want between these two branch, I want to run the EIGRP or VGP or OSPF, and even I want to use the security as well. Then what is the solution I have? The solution we have, we cannot use alone IPSEC, we cannot use alone your GRE. The solution is we can replace these alone and we can create one tunnel. Let me create a tunnel. Let's suppose the green one is a tunnel, and this tunnel is known as the GRE over IPSEC. The moment when you create the GRE over IPSEC, then what is going to happen? GRE is going to give the flexibility. IPSEC is going to give the security. So at the same time, you can run any dynamic routing protocol, plus even you can do the end-to-end encryption. So this is the beauty of the GRE and IPSEC. So GRE is going to be always there. If you want to build a virtual tunnel, it is going to build over any public network, but alone is going to be unsecure. But it's a very much flexible. If you're going to use IPsec between the two private public network, it is going to create security, but it is going to be non-flexible. So if you want to make the flexibility and security together, then you have to use GRE over IPsec. So this is the why GRE is going to be used, and the region of GRE is going to be there in the network. So I hope you understand, guys. Write your yes or no in the comment so I can come to know you understand this particular concept. Now, what is the AIM GRE tunnel? So GRE tunnel, whenever you're going to build that, okay, whenever you're going to build the GRE, let me clean this diagram. So now we have to focus GRE versus mGRE. This mGRE is going to use especially in the DMVPN. Normal VPNs only use the GRE, but if you want to use a DMVPN, then mGRE is going to happen. So whenever you're going to create the GRE tunnel, then you have to create the tunnel interfaces. Means always you have to create the tunnel interfaces between, let's suppose this is the R2, this is the R3, this is the R4. They want to build the GRE tunnel, then you can have to create the multiple tunnel interfaces, and then based on that tunnel interfaces, you can just create the tunnels between the all the side. But mGRE is going to give the flexibility. Just create one tunnel, and based on that, all you can create the your GRE tunnel. That is a multi-point GRE. Means the one tunnel is going to flexible to create the multiple GRE. Right? Clear till here? I hope it is clear, guys. Now we have to understand one more concept, guys. Whenever you use the GRE, IPsec and all, we have to understand the packet format. Whenever you're going to apply any IP packets, by any router, any interfaces, how much maximum you are going to get the MTU size. That is known as the maximum transmission unit. This is going to be your 1500 bytes. Means this interface can maximum transmit your data packets, including your IP header plus data, payload, actual data and payload. That is not exceed more than the 1500. But this is a TCP/IP, basically TCP/IP both. So by default, what happen whenever any packet is going to be there, this IP packet having the headers for TCP/IP, basically 20 bytes. So it's going to be 40 bytes by default. So 1500 minus 40, if you do that, it is going to be 1460 byte. Maximum your payload should be there in case of the normal IP packet. So this is going to be your known as the MSS. Means MSS is going to maximum segment size. So always you have to lower down your MSS. Means this is the actually payload, your actual payload. Maximum segment size is means data payload. How much data payload you're going to say send over the any internet link. Maximum packet size can be, it's very important in the GRE and IPSEC configuration, guys, because whenever you just add any IPSEC packet, any GRE packet, any mGRE packet, they're going to add more header. So if you have the more header and your MSS size is going to be greater, your packet is going to be fragmented, and after that your packet is might be not going to give the right means your traffic is not going to work correctly. So always you have to lower down the MSS, so that if MSS is going to be, let's suppose my MSS is going to be 1400, so still I can add 100 bytes header, and this 100 byte header can be added. Let me show you how the calculation is going to happen. So if you go a little bit down, I'll show you here. See, hold on. This is not, hold on, this child, you can see. So you can see MTU versus MSS. It is very important to avoid the fragmentations. It's a very important, everyone. Okay. So maximum transmission unit and the maximum segment size, it's a very important parameters. And even the tunnel configuration, when I'm going to configure, you can see these tunnels are going to be use this MTU size, and also they're going to use the MSS somewhere. It's not used, but I need to use this MSS as well. I will show you. The MSS is also going to be there. Somehow I missed that configuration. I will add it. See, here is a TCP adjust MSS. So it is written here. I was thinking I missed that. See, the TCP adjust MSS. So this is very important to just mention that why the logic is, if I talk about the MTU versus MSS, configuration are critical. Yet often the overlook aspects of the DMVPN deployment. Incorrect setting lead to a packet fragmentations. It is going to be retransmission, degradation of their application performance, and it is very going to be difficult to troubleshoot. So that's why whenever you have the GRE headers, it's going to be add 20 bytes IP header plus 4 byte का आपका 4 byte is going to be GRE headers, that is going to packet. And if you're going to IPsec, 20 byte IP header, 8 byte your ESP header, 16 byte your IB bit, right? And then 12 byte your ICB bits. Just Google it, IB and ICB bit. It's going to be full form is there, and there is a padding. So 56 bytes is going to be header is going to be there. So approximately you are going to be add 80 bytes header. So always try to send your MSS lower than 100, like means whatever you have total MTU size, lower than 100 you have to just decrease, and then you have to set your MSS. So best is just adjust on 1316. That is the best way. 1350, 1360 of the MSS, and keep your MTU is 1500 or 1400, whatever. Means whatever your value you have in the MSS, you can add 100 plus on or 120 plus on as a maximum transmission unit, where the header is going to be agree and added, and then they're going to be transmit the your packet. So that's also going to play a very important role, guys. So always if you go even the Google and try to search TCP IP header size, you're going to find the 40 bytes. You can see 20 bytes is going to be 40 byte. TCP, IP and TCP 40 bytes. So it's going to be 1540. And if you're going to add plus GRE, then it is going to be, see, it's going to be 64 bytes. GRE is 4 byte, okay? And 20 bytes is the inner header, 20 bytes is the TCP header, 20 bytes the outer header. So it's going to be 64 byte. But if you're going to add GRE plus IPsec, okay, TCP IP GRE plus IPsec, even it's going to be more than that. It's going to add around 96 byte. So that's my recommendations. Always try to do lesser than 100. Means whatever your maximum transmission unit have, you try to set MSS size maximum 1400 or 1360 or 1370 or 1350. So even my header is going to be added for any point of view. My fragmentation is not going to be happen. If fragmentation is not going to be happen, my slowness network is not going to happen, my retransmission is not going to happen, my website is going to be correctly load, my application is going to be correctly load. That's the beauty of the my this concept. Okay, guys, so I hope you understand this concept. So let me quickly walk through this particular PPT as well, so you guys can a little bit get an idea what is that. So we are discussing about that we have the VPNs network, and in VPNs we have a lot of challenges because the VPN are going to give the confidentiality, data integrity, and authentications. But the problem is we have to make the side-to-side VPN, hub and spoke VPN, Google and this full mass VPN. Those are going to create basically a lot of kind of the complexity in the network. So to overlook that, means it is going to give the your security end to end. But the problem is going to be scalable network. So that is going to be DMVPN come in a picture. This is going to give the mGRE, and they're going to use the protocol that is the NHRP. I will discuss how the NHRP is going to work, and then it is going to apply on top of the IPSEC to just make the security, how it is going to be end-to-end secure. And whenever you're going to use the VPNs, they are going to make the dynamic tunnel between the different routers via the mGRE tunnel. So it's going to be effortless, a scalable network. Dynamic spoke-to-spoke tunnel is going to be there, and GRE is going to basically, each tunnel is going to be connected with the each routers. That what I discussed in the beginning of session. But mGRE is going to be single tunnel. Here you have to, the number of branches we have, number means I have the 100 branch, I need to create 99 tunnels. 100 minus 1. In mGRE, everything is going to happen on the single tunnel. Not supported all traffic traverse must be in this GRE. If you are making the hub and a spoke, every traffic must be go via the hub. But this is fully supported dynamic tunnel on demand tunnel creation between the branch to branch also. So it's the beauty of the mGRE. And there are a lot of like it is required for the number of the small site, but if you have the high number site, that mGRE is going to be there, right? It's not scalable, but it's going to be scalable. Now we have to talk about the NHRP. It's a one of the like I can say key pillar of the DMVPN. If there is no NHRP, you cannot build the DMVPN. So what is the NHRP? NHRP is the protocol. It's similar to the ARP protocol, but ARP is going to map IP to the MAC, right? But this is going to map your tunnel to your public and private address mapping. Public and private address mapping means I'm going to tell, means this is the public IP, this is the private IP. So they are going to manage, let's suppose if I'm going topology, this public IP address means whatever the ISP is going to give the IP address, this is known as a public. Generally in the frame relo, we known as the ATM network, non-broadcast multi-access. But even in our case, it is going to fiber, it is going to be my copper, it is going to be NBMA address, that is a public IP address. So NHRP is going to map whatever tunnel you're going to do that, mapping local network tunnel with this public IP address, that is going to be in NBMA address. So you can read it here. Next hop resolution protocol serve as a control plane intelligence and makes DMVPN dynamic tunnel creation possible. If this protocol is not going to be used, you cannot make any DMVPN communications. Often describe as the ARP for the non-broadcast network. So similar, it's a ARP, address resolution protocol, but ARP is just going to IP to MAC, but it is going to map your public to the private IP address. NHRP performs the critical mapping function, resolve tunnel overlay IP address and their corresponding NBMA underlay address. This is what I was talking. Means whenever create the tunnels, right? Whenever I want to build a tunnel, so we have to get tunnel interfaces. Every router, I will show you. Probably in this configuration, you're going to find out. See, every router is going to require tunnel interface. See, this is the you can see, no, this is not tunnel. This is the NBMA address. Here is the interface. So what is going to be required corresponding to this IP address? What is the public IP address going to required? This mapping is responsible. This mapping responsible by the NHRP. This is the key factor where it is going to do any kind of the mapping. So this is going to do the all mapping or public and the tunnel IP address. This is what they're talking. That is typically public internet IP address. NBMA is nothing. Underlay public IP address. I'll discuss what is underlay. Under is nothing. This tunnel, this is known as the underlay. Means this public IP is going to talk. Then only we can form the tunnel. So underlay is basically basic IPv4 reachability or B6 reachability. Basic IPv4 or IPv6 reachability, that is known as my public means the underlay. But once underlay is going to be reachable, on top of that you are going to build a tunnel. Means any GRE IPsec, that is known as your overlay. Even in the SD-WAN, we are going to use the same concept. Any SD-WAN solution, any ACI solution, VXLAN solutions, they are going to be use the same kind of fundamentals. Clear? Okay, so moving next, this is going to be core function. Without NHRP, router would need static configuration, table mapping every tunnels. So if you're not going to use the NHRP, then you have to do everything on the mapping manually. It's going to be very complex, very kind of the like bad network design. So NHRP always going to be used, which is going to be map automatic everything for any kind of the plug and play connectivity. So core function, it's going to register your spoke with the NVMe tunnel with the hub. That is a next hop server. That is your hub router, central router, creating a dynamic tunnel database for the every spoke router. Resolution, when a spoke need to communicate with another spoke, it's query to NHS. That is a hub router. Let's suppose here, if he want to make to connect to here, he will first request him, then he will give the mapping how to connect to this particular spoke, and then it is going to build a tunnel. So this is how it is going to maintain the all table NVMe to public IP address to tunnel interface configurations. Then the maintenance, that's continuously it is going to verify, validate registration through the keep alive and the like other entries informations, ensuring that mapping database are remain accurate and it is not going to be removed. Clear? So this is the NHRP guys, and it is going to be very important. And there are a lot of things we have to understand. Now we have to understand in DMVPN we have the multiple phases. In DMVPN, if I go here, they use the multiple phases. So let me draw the table. So this is the DMVPN phase 1, the DMVPN phase 2, DMVPN phase 3. So let's understand what is the difference between these all three pages. I will give the quick, crisp and short answer for these differences. If I talk about DMVPN phase 1, means your all traffic, means if you want to make the any communication, means any branch want to go any other branch, you always go, traffic will go via hub router only. Hub router. Means if you want to go from one branch to another branch, it will go always hub. This is the phase 1. Phase 2. Okay, if I talk about the phase 2, means this is the phase 2. The first packet, whatever the first packet resolution is going to happen, the first packet will go hub, and then second packet spoke to spoke. Okay. In phase 3, means phase 3, if you want to make any spoke to spoke connection, no packet required to go on the hub. No packet required, go at hub. You can directly create tunnel between the spoke to spoke. Let me explain diagram so you can understand this one. Let's suppose this is my phase 1 topology. DMVPN phase 1. DMVPN phase 1. In that case, this packet will first go a spoke, a hub, then it will come to the spoke. Always, it is going to be always. Means it is going to act as a legacy VPN mapping. Legacy VPN hub and spoke topology. No difference than that. Means always you have to go hub and then you have to back to the spoke. This is the problem with the DMVPN phase 1. So that's not recommended to use. Now, let's talk about the phase 2. Phase 2, DMVPN phase 2. DMVPN phase 2, if this branch want to talk to this branch, very first type packet will go via this one. This is the very first packet. Okay, guys. But once this first packet will go, then after it will build the dynamic tunnel directly. Means they will directly talk to each other. So this will create the dynamic tunnel spoke to spoke. Clear? Means very first packet will go in the hub and then it will create the spoke to spoke. And one more problem, if you're going to use the phase 2, it will not support any summarization. Network summarizations. I hope you guys know what is the summarizations. It will not support. That is a problem. Phase 2. Phase 2 is good. The very first packet is going on the hub and then it is making the dynamic tunnel, but it will not support the summarizations. Now, what is the best solutions we have? The best solutions we have, that is a DMVPN phase 3. DMVPN phase 3. In this phase 3, if these two branches want to talk to each other, they will never go to the any kind of the communication to the hub. They will directly build the dynamic internal. Dynamic. Phase 1, Phase 2 also can build that, but Phase 2 always send the first packet, then it build the tunnel. But in this Phase 3, it will dynamic build the tunnels, and then they can communicate each other. And also they support the network summarizations. So if you're Phase 3, you are going to get every flavor of the understanding. So let's understand in this my PPT as well. So you are going to get here some differences between Phase 1 and Phase 2 and Phase 3. Let me see. Yeah. Okay, so Phase 1 is like it is going to be traffic button. Always, all spoke traffic must go via the hub, and each router forwarding packet between the spoke and hub become the potential bottleneck for the single point of failure. Means Phase 1, if I'm going to use, still I have the dependency on my hub routers, and this is going to create a problem, right? So if you have the very small network, you can use that, but hub is always going to be your bottleneck. It is going to create a problem, and there is no spoke to spoke tunnel is possible. Phase 2, if you're talking that, direct spoke communication is possible. Spoke send initial packet via the hub. That's I mentioned. The very first packet is going via the always hub locations. Then it can create the NHRP resolution, and they can make the further spoke to spoke tunnel, and then they can do the further communications. But problem with that, they having no network summarization. You cannot do route summarization with these particular solutions. But if we talk about the Phase 3, this Phase 3 is make the direct spoke to spoke communication, direct tunnel establishment. They can do the your all summarizations. We have to use two command, NHRP redirect at the hub and NHRP shortcut on the spoke router. I'll explain what is the meaning of the shortcut and the redirect command, and I will do in the lab. Then we're going to be understand each and everything. So this is all about the Phase 2 and Phase 1. So here you can see here, mGRE point to point not supported all hub, supported by the manual NHRP resolution, automatic NHRP direct trigger. Always traffic go via the hub. This is going to be spoke to spoke, but first traffic is going via the hub. This is going to be always going to use the IP NHRP redirect and the shortcut command, and no traffic is going to hub, and it is going to be always independent of the tunnels. So this is how modern is going to be used. Choose Phase 3 if you have the longer site, larger site, more than 100,000, 50, you can use. If you have the branch less than 50, 100, you can use the Phase 2. But if you have the very small network, like less than 10, you can use the normal Phase 1 solutions, right? So I hope you guys understand this one. And then the mGRE means the MTU and MSS I already explained, right? And like if you want to plan to implement the DMVPN, right now DMVPN are not using that much, but still many customers are using, and many even if the CCIE and the CCNP ENARSI course, this course include this DMVPN concept, so you should know about it, because this DMVPN is going to be very important, very useful for your kind of communications. And in every organizations, if they are not using the SD-WAN solutions, they're using the DMVPN only, because it's very intelligent. Even prior the SD-WAN, DMVPN was only based like the your key architecture to design your WAN. So design redundancy, you have to make sure whenever design the DMVPN solutions, we have the primary hub and secondary hub. QS policy, make sure you implement rightly, so right traffic is going to prioritize. You maintain the proper documentations, configuration, LLD, HLD. It is going to be also very important. Use always IPSEC, so your security is going to be there, right? You always integrate the monitoring, proactive monitoring tools are going to understand which channel is flapping, which interface is going down, and which NHRP is going to be not resolving the addresses, and DMVPN state also you have to monitor. This is how it is going to happen, and then we have to build the our lab. So I hope I cover whatever required for this particular DM VPNs and VPN concept, and you guys understand till here. Now the second phase, we have to understand what is the underlay configuration and how we can build the underlay configuration in the lab. So I'm going to do the basic underlay configuration, and then after that I will show you how to create the Phase 1 tunnel. Okay, just give me 1 second, guys. So this session is going to be little bit long, but you're going to get a lot of things. So in this topology, okay, let me put it here. So DMVPN lab by GuiNet. This is the blank lab, completely blank lab. Okay. And let me make it Okay, and I can just use these as well if I want to make it a little bit drier, so I can make that. Let me use that. Okay, it's too long. 24. Okay. So this is the DMVPN lab. Hold on, guys. Give me 1 second. Okay. So this ISP router, we have to configure these public IP addresses. So let me start with the ISP router first. This is my ISP router. So on this ISP router, I will do the all public interface configuration. So let me go open. I believe some issue with the internet. It's unstable for some reason, but let me check if I can make it happen. Okay, now it's working. So I'll go in the host name and make as a internet ISP. Something goes wrong. Okay, and do show IP interface brief. And I will assign the IP address. This is the 0 by 0 203.0.0.13.1. So interface is going to my gig 0 by 0 IP address 203.0.113.1. I'll use here. Okay, this is going to be all one here. Okay, and 255.255.0, and I'll use no shut. So this is the one interface. On this I will use 14.1. Okay, so I will just go 0 by 1, and then I will just use 14.1 here, 14.1 and no shut. Then I'll go here and 0 by 2, 15.1. Hold on, guys. 0 by 2. And I'm going to use the 15.1, no shut. And then I will go in gig 0 by 3, gig 0 by 3. And it is going to be 16.1, no shut. Okay, and do right. That's all. So this is my ISP core, right? So I need to build the underlay connectivity. So I'm just assigning the IP schema, and then I will make sure I have the first underlay. Then we'll try to build the IPSEC, GRE tunnel between the branches. This is the one thing, right? I have done. Now I'll go in the hub router. Hub router, I need to create two things. I will create one of the tunnel, and first I'll create my one of the router, and I'll give the default route pointing to this ISP. Every router has the default route pointing to this router, so they can make the underlay connectivity. So I will go here, and this is my interface gig 0 by 0. So interface gig 0 by 0, and IP address is going to be my 203.10.10. Sorry, 203.0.213.255.255.255.0. No shit, and I will give IP route 0 dot, sorry, 0.0.0, 0.0.0, 2030.113.1. That's all. Do right. So I'm pointing the default route here. Now I'll go in the spoke 1. Spoke 1, I'll go, and I will configure host name. I didn't change the host name. Let me change the host name as well now. Here, hub site. Okay, this is going to be spoke 1. Do show interface is going to be my gig 0 by 1. IP address is going to be 203.0.114.2.2. No shit. Let me try to ping my ISP side, it is pinging or not. So I'll hold on. Gig 0 by 1. It's not pinging. Why? Gig 0 by 1 203 0.14.1. Check guys, show IP interface brief should be reachable. Okay, so this is fine. This link is connected on here to here. ISP. Let me check here as well. Okay, that's fine. What is the problem then? 2030.114.1 self is reachable and 2. Yeah, it's reachable now. It was taking might be time. Let me go again here and try to ping. Yeah, it is reachable. So I will add one of the static route here. Pointing toward 2030.114.1. And now I need to ping my hub location. This is my NVMe address. This is my NVMe address. 2030.13.13.1. So I will go here and ping 203.0.113.2. And it should be reachable. Because this is must be going via this one and it should be reachable. To show IP interface brief. Yeah, it should be reachable because do show IP route. Okay, I forgot to put the static route here, no? So for some reason, IP route, there is no default route available. So let me put default route here as well. 2030.113.1. Now let me try. Should be reachable. I put it that address. Do show run pipe include IP route. Hold on, guys. I believe there is some issue. Let me ping this IP address. It is reachable or not. Okay, so this is not reachable. And this is the region. So why it's not reachable? Gig 0 by 0. Let me check. We have this IP address and ISP side. This is the IP address. So gig 0 by 0. Yeah, it's absolutely fine IP address. Yeah, it is also 2030.213. 2030 dot. Okay, 213, not it's 113. Sorry, it's my bad. There is a mistake now. I have done the mistake. Hub side. Sorry, guys. This IP should be not 213. It should be 113. This is the wrong subnet. Okay. Now let me try to ping again. Ping this IP address. .1 first. Yeah, now reachable. Now if I go in the spoke, should be reachable. And it's reachable. So you have the underlay reachability from this to this. Now similarly, you have to do the underlay reachability from this location as well. Spoke to as well. So I'll go spoke to. Simply, I will just do the configuration. So I will go here. And host name is going to be my spoke 1. Do show IP interface brief. And I will assign the IP address. That is a gig 0 by 2. Gig 0 by 2. And IP address is going to be this time is going to be 203.0.15. 203.0.115.255.255.255.0. No shit. I'll first ping point to point, whether it's pinging or not. Then I'll go for the next step, because if it's not pinging, then I have to troubleshoot. Sometimes make mistake as well. Should be reachable first. One is configured on the ISP side. So IP interface grid. Let me check. Yeah, 0 by 2. 0 by 2. And here also should be on 0 by 2 now. 0 by 2. Let me check on the spoke 2. Okay, that's correct. We'll try one more time. It will ping. Sometimes it take a time. Yeah, it's pinging. You can see. So now it's pinging. So now I can do the IP route configuration. I will give the static default route pointing to the this desktop, and then I will ping my hub as well. And I'll make sure I have the underlay reachability with the hub. So I can go here, do ping 203.0.113.1 should be reachable. Yeah, it's reachable. Then I'll do right. I have the underlay with the spoke 2 as well. Now it's time to spoke 3, and then we can go for the next step. So I will go here and config t host name is going to be my spoke 3 and do show IP interface brief. And interface, I'll go and configure gig 0 by 3. So gig 0 by 3 and IP address is going to be my 203.16.2. 203.0.116.2 to 55.255.255.0. No shut. I'll wait for a while. And I need to ping point to point. Meanwhile, let me check. Show IP route. I'll give the another static route as well. 203.0.116.1 and do right. Let me try to ping whether my gateway is reachable or not. So I will first go and try to ping this address. If it is reachable, then I'll go and ping my hub location. It's not reachable. Yeah, it's reachable. So now I'll ping my 113.1 and should be also reachable now. Yeah, wait. So guys, we build the underlay connectivity. This is the underlay connectivity, means my all public IP address, which is hosted in the different branch, they able to reach. This is the very first step. If you don't have the underlay reachability, you cannot form the overlay reachability. So now we have to create tunnel interface. We have to create the configurations for the phase 1. We'll do phase 1, then phase 2, then phase 3. So I will try to complete the phase 1 today. If not possible, we'll have another master class on the phase 2 and phase 3. But let's create the tunnel interface. I'll go on the hub locations and I'll create the tunnel interface. I'll go here, interface tunnel. I'll use the tunnel 0 and IP address is going to be 10. Hold on. 0.0.1 to 55 to 55 to 55.0. So show run, let me show run interface tunnel 0. I will copy this configuration. Okay. I will go in the spoke 1, config t, and I will paste it here. This is going to be .2. Okay. This is going to be .2 only. I'll go here and I will paste here. This is going to be hold on. This is going to be .3. Okay. I'll go here, paste it. Do show IP interface brief. Now we'll check it. We have .4. Okay. Tunnel is required. Do show IP interface brief. This is .3. That is fine. I'll go here. Do show IP interface brief. This is my phase .2. That is also fine. And here is a .1. So you have to get a tunnel interface. Now we have to understand. Right now, if I'm going on the any locations and try to pick tunnel, it's not going to build a tunnel. Let me try. If I'm in this here, let me show you. If I am trying to ping my 10.0.0.2 tunnel, which is this IP address, from the spoke, means from hub to a spoke, it is not going to ping as of now. It's not pinging because we not have the DMVPN tunnel, means GRE tunnel or mGRE tunnel. So we have to build the tunnel. So how the tunnel is going to build? So to build a tunnel, we have to use the official certification guide. I'll show you how you can refer and create a tunnel, and I'll explain each and every command informations as well. So if you go in the dynamic tunnels, so the same step, whatever I cover, there is written here why it is going to use. This is GRE tunnel and all. NHRP and all. But let's understand step by step. This NHRP already explained. But how the phase 1 tunnel is going to be created. This is the DMVPN phase 1, this is the phase 2 and 3. The phase 2 and phase 3 are same. Only the difference is in phase 3, you can do the network summarization, and in phase 3, it's going to be always a spoke to spoke. There is no hub dependency is going to be there. So if I want to create my phase 1 tunnel, so you just have to follow this official documentation if you want to create. And then we have to understand each and every line by line configuration meaning. Okay, so where is the configurations? Give me 1 second, guys. Okay, see, this is the phase 1 configurations. Okay, so in phase 1 configuration, if you see here, I created tunnel interface, I give the IP address. Now, ignore this bandwidth command. I already explained what is the MTU command and what is the adjust MSS command. These things you know that. Just follow this mapping, not this. This is the hub locations, okay? And then you have to create the NHRP network ID. This should be unique. Network ID is going to be unique for your all configurations. And then after you can just create tunnel and source interface, tunnel mode GRE. This all is going to be there. And based on that only you can do the all configurations. So if you want to build the phase 1 configurations, you have to adjust the TCP, adjust MSS, and then you have to create the MTU. Then you have to go and give the NHRP mapping, that is a multicast dynamic is going to be there. And then after basically you have to go and give the mGRE as a tunnel mode. And this is a tunnel source interface. But in the spoke, you just have to follow this one. Again, your bandwidth is going to be there, IP is going to be there, but you have to do this NHRP mapping. Means your public tunnel means public IP address with a private tunnel IP address. And you have to give the multicast address. This is your NBMA address. This network ID should be same NHRP. If you can use the NHS NHRP authentication key as well. I'll show you how the authentication key is going to be there. Might be it's not cover here, but might be in my slide it's going to be there. Let me show you. Here is the configuration. This is a phase 2. Phase 1 is there. So we can use the additional command next hop cell PIGRP. Why it is going to use, I'll explain that. But here you can see there is a NHRP authentication command. We can use that authentication as well. Okay. And TCP adjust MS. So let's do that. How it is going to happen for the phase 1, and then we can do for the other configurations. So show an interface tunnel 0. I will explain each and every configuration meaning of this hub locations. So I'm in the interface tunnel 0. The very first thing, IP MTU, let's suppose I'm giving the 1400. Then I will give the second step, IP TCP adjust MSS is going to be 1360. This is the second command. Then after, what is next? In next command, I will do the NHRP mapping. So in this case, this is my hub location. So it is going to be do the dynamic mapping. So I will use the IP NHRP multicast dynamic. Hold on, IP NHRP. Okay, so I use a map now. Sorry, I forgot map. Multicast dynamic. Okay, this command I need to do. This is going to give the dynamic mapping. I will explain later on how it is going to happen, dynamic mapping. I will show that dynamic mapping as well. Now I want to give the authentication key. As I mentioned that authentication key also is very important to secure my NHRP is going to be authentication. So key should be same both side. If it is not same, it is not going to map your NHRP. Now what next? After that, you have to give the unique NHRP network ID. NHRP network ID. And this can be any number from this range. I can use the 1, let's suppose. And then you have to give the, what is the tunnel source? Tunnel source is your public IP interface address. In that case, we are going to use this as a source. This 0 by 0. 0 by 0. Okay. This is going to my source. Okay. Now, after that, what is my tunnel mode? I will make this tunnel mode as a mGRE. So mode is a GRE multi-point is going to as a mGRE, and you can want to secure this tunnel, then you can keep the tunnel key. Means if the key is going to match on both sides, then only it is going to be make the tunnel configuration. That's all. So this is my hub location, and you can just write this configuration. Now, how I can create the configuration for the spoke locations? It's going to be similar, but few changes you have to make. Let me show you what changes you have to make. So show run. Give me 1 second, guys. Show run interface tunnel 0. This is my hub location configuration. I'll copy this configuration. Text. I'll go here and I'll paste this configuration. In hub locations, right? This or IP already assigned, that is not needed. IP redirect is going to be there, not needed. But you require this authentication also needed on the hub side. I mean the spoke side. This is required, mandatory, should match. This network ID should match. Tunnel key should be match. MSS should match. These all should match. But tunnel mode is not required the multi-GRE in the spoke side. This command should replace with the tunnel destinations, and this destination address is going to be your public IP address of this one in every spoke sites. So what is that? 203. Let me go it here and give that. This need to be replaced. Into that. Hold on, guys. So I will go here, and this is going to my destination is 203.0.113.2. This is my tunnel destinations. Clear? Key is also going to be there. So just only this change is going to happen. Only one change is going to happen. In addition of that, two more changes you have to do that. That is only under the NHRP. And what is that? You have to do the manual mapping for the NHRP. In that, you have to use the IP NHRP, and you have to give the map multicast, and this is going to be your NBMA address of the hub location. Okay, this is the one command. The second command you have to use the, again, your NHRP mapping, but this is going with the your tunnel IP address of the hub locations. Along with that, you have to give their NBMA address, means their public IP address. Means this mapping is basically I'm doing to whom you make the NHRP communications. So that is my tunnel address 10.0.0.1, and that is the corresponding to my public IP address. Now one more command I need to add. What is my server IP address? Means NHRP server. That is the IP NHRP, and that is going to be my NHS address, which is NHS 10.0.0.1. This is my final configurations. This is my final configuration, which is going to require in every tunnel. Let me check quickly with the configuration. It's matching or not. I will explain these two commands. Next hop self EHRP 100 and split horizon. What does that mean? But you can see here, MTU is there, tunnel IP is there. You have to give the authentication. You have to give the mapping. That is the IP NHRP map that is required. That is IP NHRP map that is going to also required. Network ID is also required. We are using network ID. Yes, we are using network ID. And adjust MSS already be done, and that's the tunnel destination. So I believe we are good. So now if I just copy this configurations, and I can paste this configuration on the my all the routers. Same. Means I'll go in the spoke 1 and I'll paste it here. That's all. This is the very first router, okay? And then after what I can do that, I'll go in the spoke 2. The same configuration is going to be because already we assigned the IP address. So I'll just copy these configurations. This is also done. And then I'll go here also. And this is also going to be done. Now we have to check whether my DMVPN tunnel is there up or not. DMVPN. So something went wrong. Show DMVPN. Yeah, it's trying to create a tunnel, but there's no tunnel. So DMVPN. It's also not initiated. Okay. So this is the static, but for some reason the tunnel is not created. So we need to troubleshoot why tunnel is not created. So show run interface tunnel 0. IP authentications, that is going to be there. Let me just quickly check with my this book. IP NHRP map, tunnel source is going to be there. We can quickly have a look. What is the wrong with this tunnel? So we have the IP address, and then we have the IP NHRP, that is fine. We have the NHRP authentication key, that is also fine. That is a tunnel mode, is this one. Source is this one, that's not wrong. Okay, I found the, see, the wrong is this tunnel source need to be changed. For spoke 1, I got the problem. I just copy and paste. This tunnel source should be this one, 0 by 1. This is the problem. Okay, guys. So I need to change the source, and that's why it's not coming up. So this is going to be tunnel source, this one. Okay. Now I'll go here and show run tunnel interface 0. This tunnel source should be 0 by 2, not 0 by 0. So I just copy paste and make the mistake. So interface tunnel 0. This is going to be my 0 by 2. Okay, so this is the wrong. And if I go here, show run interface tunnel 0 also. Interface tunnel 0. This is going to my 3. Let me check here, 3. Now let me check here again. Show DMVPN. Yeah, you can see these all tunnel come up. But very important, guys, let me explain. Do right. Let me do right. We end with the last sections. Okay. So my tunnel is come up, right? And after that, if you see here, this tunnel came up. These all tunnels showing dynamic because it's a mGRE tunnel. So it's a build the dynamic tunnels. But in the spoke, it is going to be static tunnel. Every spoke, it is going to be static tunnel. DMVPN. DMVPN. So this is going to build the static tunnel. This is the S. But in phase 2 and phase 3, it is going to be dynamic also. It is not going to be static, but here it's a complete static because we have make the static DMVPN. This is the static also. And if you go here and run the command, show DMVPN, it also going to be static tunnel. Clear? So till here we build the everything a static tunnel. Now what next, guys? Next is if I go in the hub and try to ping my these addresses should be reachable now. Because they build the tunnel, so all tunnel address should be reachable. See, 2 is reachable, 3 is reachable, 4 is reachable. But now if I'll create loopback address on the every routers, if I create the loopback address, let's suppose I go and create the loopback address and I want to make that as a LAN reachability. Interface loopback 1, IP address 1.1.1, okay, 255, 255, 255, 255, and I'll go and configure a tunnel interface loopback 2, IP address 2.2.2.2, 255, 255, 255, 255. Sorry. This is done. I'll go here and create another interface loopback 3, IP address 3.3.3.3, 255, 255, 255, 255.255. This is also done. Show IP interface brief. This is also done. And I'll go here and create tunnel interface loopback 4, and I create this IP 4.4.4.4. So 255, 255, 255, 255. So do right. I created loopback. Now I want to make the loopback reachability. It is not possible. Tunnel are reachable, but the loopback are not reachable. So to make them reachable, what I have to do that over mGRE tunnel or GRE tunnel, we have to build the any kind of the routing protocols. And for that, I'm going to use the EIGRP routing protocol. And this EIGRP routing protocol is going to be give that variations to advertise my loopback addresses from one location to another location. So if I go in from the hub location and I try to ping loopback 2.2.2, it's not going to ping because this loopback routing doesn't have, means hub doesn't know about it 2.2.2 in routing table. So if it is not going to know, then how it is going to make the reachability? It's absolutely not possible, guys. So if you check here, show IP route, you are not going to find this 2.2 is available. So I can just go and enable the router. OSPF also can enable, and I can use the network 1.1.1, 0.0.0.0, and also include the tunnel interface 10.0.0.0, 0.0.255, done, and show run section EIGRP. I will copy and paste for the routers. All the loopback is going to be changed. So this, hold on, I lose that access. What happened? Sorry guys, I believe I lose that connectivity. Okay, I believe I'm fine. I can, okay. So for this, I can go here. Let me copy it again from here. Okay. I will copy it here. This is going to be changed. For the spoke to, I'll just copy this one and paste it here. Spoke one basically. And I'll paste it here. Okay. And for the spoke to, it is going to be 3.3.3.3. See, we have the EIGRP neighborship. Oh, I lose this connectivity. Okay. So I'll go again in the router 2, spoke to. I need to paste these configurations. So I will go here and paste it. And this I'm doing also EIGRP neighborship. I'm losing the connectivity again, but I will try my best to complete this lab. Let me try this one. And okay. This is also done, guys. So we have the EIG. If you go in the hub locations now, if I go in the hub locations now, and you go in the hub router, you see show IP EIGRP neighbor. We have the 3 neighbors. So now if you check show IP route, we have the all loopback addresses are available. But still, if I try to ping 1.1.1, extremely sorry, there is some internet issue. I never expected this is going to happen in the last moment, but yes, it is having, so I cannot do anything. So if I'm going to ping 2.2 with source 1.1.1, it is reachable. But the problem is, if I'm in the spoke 3 now, and if I try to reach my locations for any hub, right, like any spoke site, means if I'm there and if I try to reach my, let's suppose I want to ping not hub, I want to ping the 2.2.2. With the source here, we created the 4.4.4. It is not going to ping. Why it is not going to ping? Because there are the EIGRP default behavior. By default, split horizon rule is going to be enabled, where if you are learning any route, if you go and understand what is the split horizon rule in EIGRP, split horizon rule in ENARSI. So this is going to tell you split horizon rule prevent the router from advertise the route back to the same interface. So see what is happening. You're getting a route from this ENARSI neighbor. You're trying to advertise the same route on the same interface because you need to advertise the route to the spoke from the same ENARSI interface from where route is learning. So by the help of the split horizon rule, this route is going to be create an issue. If you go in the spoke 1, let me go in the spoke 1. And if you check show IP route, you're not getting route for the loopback 3 and 4. Why? Because they are advertising to the hub location, but due to the split horizon rule, it is not advertising back to spoke 1. And similarly, if you go the spoke 2, it will not get the 2.2 loop back on the spoke 2. If you go in the spoke 2 now and you check the routing table, so you just check the routing table, show IP route, you are not going to get this route. 2.2 is not available. So to avoid this behavior of the IGRP, we have to go in the hub locations and because we want to get this route. So I will go here on tunnel interface tunnel 0 and no, and there is a command known as the, what was the command? IP split horizon, no, let me go here, no IP is split horizon EIGRP and we are using the 100. The moment you do that, now you see, you are must be start getting the your remote log. See, and now if I'm going in for the spoke route and try to ping this 4.4 with the source 1.1.1, it should be reachable. Sorry, source should be 2.2.2. So it is reachable. So if you trace this subnet 4.4.4.4 with the source 2.2.2, this will first go in the spoke, and that means first it will go hub and then it is going to the spoke. This is how it is going to happen behavior. Even if you go for the any kind of the site 3 location, and here also you check show IP route, you must start getting the route for the 1.1 and 2.2 and the 3.3. But if you're trying to trace here, this 2 subnet with the source 4.4.4.4, it is going to be via hub. So all communication must be going via the hub. Let me show you the live trace. See, this go 10.0.0.1. What is this one? This is my hub location and this is my further spoke location. That is a spoke 3. And if I'm doing the trace from the spoke 3, it is going the first hub and then it's going to the spoke 2. So this is how it is going to happen. So this is the meaning of the command. Sometime in the interview, when you're going for the DMVPN, they will ask what is the meaning of the split horizon. And no IP next hop self means you are not, it is not recommended. Always you have to use, but if it is there, what happened when we're going to use the EIGRP, it will send the router itself as a next hop as a that route. So you don't require new iOS, it is going to be supported. So if you want to know more about that, so the meaning of this is means the hub router is not going to set the next hop for that particular route. So this command noise by 100 not valid Cisco ASA command, right? However, IP next hop self is a valid command. So earlier it was the old command, but still it is going to be used in the DMVPN. But now it is not recommended. That's why I didn't use that one. It's not going to create any problem. Even if you want to ignore that, you can ignore that. But this command is very important, guys. Split horizon. If this is not going to use, your router is not going to receive the route. Even your HRP neighborship is up and working. So every router even go for the spoke 2 and you check the EIGRP neighborship. Show IP EIGRP neighbor. It is going to be showing the hub location. This is spoke 2 also show IP EIGRP neighbor. It is going to be at the spoke location. You go here, show IP EIGRP neighbor. It is going to the hub location. Sorry, but in the hub locations, show IP EIGRP neighbor. It is going to the my all site and show DMVPN. This is going to be all dynamic tunnels. And if you check the details, it is going to show all the dynamic tunnels. And if you go for the spoke locations, show DMVPN, it is going to show as a static tunnel. And detail you want to say, you are going to get more detail also from here. So this is a phase one, guys. And for phase two and phase three, there are four new configuration have to do that. Means there are some minor changes going to happen. Tunnel mode as a multi-point in this phase two, and phase three we have to use the NHIP redirect and shortcut. So I will arrange one more session. It's going to be very long if I'm going to test these all things. So I hope you guys understand at least DMVPN concept. What is IPSEC? What is GRE? What is a VPN? What is a GRE over IPSEC? Even I will integrate the IPSEC over this DMVPN to just make the encryption end to end. So that is going to be a separate session for that one. Okay. So I'm closing the session till here, and please write your feedback, comment if you really like this session. Just share your comments or any feedback, so I can just try to take as a note. And if any improvement is needed, I will try my best in the next lecture. Thank you so much. Have a great day. Bye bye. Take care.